Hello, welcome. In the previous tutorial, we look at confidence interval for mean for large sample or a known population standard deviation. If you have not watched that, you can check the link in the description area below. Now in this tutorial, I'm going to take you through confidence interval for mean for small sample and unknown standard deviation, and that's a T distribution. Now, some of the characteristics of the Z distribution are the same as the T distribution, and some are not the same. Just like the Z distribution, the T distribution is also bell-shaped. Just like the Z distribution, the T distribution is symmetric about the mean. And also the T distribution has a mean, median, and mode to be equal, and is equal to 0. And then, just like the Z distribution, the T distribution never touches the x-axis. But they are different on the basis that for the T distribution, the variance is greater than 1, and it is based on the concept of degree of freedom. And for the T distribution, as the sample size increases, it approaches the standard normal distribution. And the formula we are going to use in this topic is x bar minus T multiplying standard deviation over root n. And at the other side is x bar plus T multiplying standard deviation over root n. Under the large sample, we use Z over here, but in this topic, we are using T. Now, in the previous video, I wrote sigma here, that is population standard deviation. But in this video, I'm writing small s, which is a sample standard deviation. What this is telling you is that before you can use the T, then your sample size should be less than 30. At the same time, the standard deviation should be a sample standard deviation. Now, if you have any question where the sample size is more than 30, but the standard deviation is a sample standard deviation, you still have to use the Z. You consider that standard deviation as a population 1 and use the Z. Now, in case you have a question and the sample size is 30 or more, but the standard deviation is a sample standard deviation, since the sample size is 30 or more, you just consider that sample standard deviation as a population 1 and you still use the Z for it. Also, if you have a question and the sample size is less than 30 and the standard deviation is a population standard deviation, you still use a Z for it. The only requirement for the T is that the sample size should be less than 30. At the same time, the standard deviation should be a sample standard deviation. You must meet the two conditions to use the T. So you can also write the formula as x bar plus or minus T multiplying standard deviation over root n. Also, under the Z distribution, I gave you some common confidence levels and their various Z scores. And I also show you how to find them yourself using the Z table. But in T distribution, I can't give you any T score for any confidence level because the T scores change anytime depending on the sample size. So it means that for every question, you have to make sure you find a T score. Now, to find a T score, you will need some two things. And they are 1, alpha over 2, and the second one is degree of freedom, DF. Note that alpha is equal to 1 minus C. So you can rewrite alpha over 2 as 1 minus C over 2. C means level of confidence in decimals, okay? And then alpha is called level of significance, okay? And to find DF, that is degree of freedom, it is n minus 1, the sample size minus 1. So let's take some questions on how to find the T scores before we go to the estimation of the confidence interval. Use the T table to locate the value of T under the following conditions. A. The sample size is 12 and the level of confidence is 95%. So to solve this, first you convert the 95% to decimal, and that will be 0.95. So you take 1 minus 0.95 all divided by 2. When you do that, you get 0.025. Then you also find degree of freedom. That is n minus 1. So our n is 12. So 12 minus 1 will give you 11. So you go to the T table. Now when you take the T table, you check where they've written 1 till. Okay. And then you check for the 0.025 on that line. So we have 0.025 here. So look at this side. They've written DF here, degree of freedom. So you check for 11. So this is 11. Now, then you check the 0.025 against the degree of freedom of 11. So that will give you 2.201. So the answer for question A is 2.201. Now, there's another way of checking it. You can just say 1 minus C without dividing it by 2. So if you use 1 minus 0.95, you get 0.05 without dividing it by 2. You can check 2 tails. You can check where they've written 2 tails. So you see that you get 0.05. Against the degree of freedom of 11, you see that you get the same answer. But please use the first method I show you, 1 minus C divided by 2, and check at 1 tail. Question 2. The sample size is 9 and the level of confidence is 95%. So we convert 95% to decimal, and that will be 0.95. So we have 1 minus 0.95 divided by 2, and that will give us 0.025. So when we check the degree of freedom will be 9 minus 1, which is 8. So let's check 0.025 against a degree of freedom of 8. So that will give us 2.306. This is a degree of freedom of 8. So we get 2.306. Now look at question A and B. We have the same confidence level, but we didn't get the same t-scores. Yeah, that is because their sample sizes are different. You see that. Now let's go to question C. The sample size is 20 and the level of confidence is 90. So we convert the 90% to decimal, and that will be 0.9. So we have 1 minus 0.9 divided by 2, and that will give us 0.05. And the degree of freedom will be 20 minus 1, that is 19. So let's check. 0.05. Please check at 1 tail if you divide it by 2. So 0.05. Then we check degree of freedom of 19. So let's trace it down to 19. It will give us 1.729. So the answer for question C is 1.729. So let's look at question D. The sample size is 8 and the level of confidence is 99%. So let's convert 99% to decimal. That will give us 0.99. So 1 minus 0.99 divided by 2 will give us 0.005. And the degree of freedom will be 8 minus 1, that is 7. So let's check 0.005 against degree of freedom of 7. So this is 0.005 at 1 tail. Please be careful, don't go and check 0.05. 0.005 against degree of freedom of 7. So that will give us 3.499. So the answer for question D is 3.499. So now let's take some questions on confidence interval. Example 1 says, 10 randomly selected Independence Hall guys were asked how long they slept at night. The mean time was 7.1 hours and the standard deviation was 0.78 hours. Find the 95% confidence interval of the mean time. Assume the variable is normally distributed. So to solve this, when you look at the question, they've given us a sample size of 10. So our n is 10. And then we've been given a mean time of 7.1 hours. So our x bar is 7.1. And then we've been given a standard deviation of 0.78. So the small s is 0.78. Now, how do I know whether the standard deviation given in the question is a sample standard deviation or a population standard deviation? It is about reading the question carefully. The question says, 10 randomly selected Independence Hall guys were asked how long they slept at night. So you asked 10 sample, and that sample gave you a mean. They said the mean time was 7.1 hours. So this mean is referring to the mean of the sample of 10. Now when you look at this word, and this is a conjunction. So it brought and before saying that the standard deviation was 0.78. It means that if the mean is referring to the sample, then the standard deviation will also refer to the sample. So that makes it a sample standard deviation. Even though the question didn't say sample standard deviation. You have to know that yourself from how they've written the question. Okay. So the standard deviation here is a sample standard deviation. So next we find our t. So to find our t, we need alpha over 2 and degree of freedom. So let's find alpha over 2. So alpha over 2 will be 1 minus c over 2. That is 1 minus 0.95, that is 95%, divided by 2, and that will give us 0.025. Then the degree of freedom will be 10 minus 1, and that will give us 9, because the sample size is 10. After getting the alpha over 2 and then the degree of freedom, then we go to the t table. So our alpha over 2 was 0.025, and the degree of freedom was 9. So let's check 0.025 at 1 till, where they've written 1 till. So let's check 0.025 against degree of freedom of 9. We will get 2.262. So the t-score is 2.262. So after getting the t-score, then we recall the formula for the confidence interval. X bar plus or minus t multiplying standard deviation over root n. You can also write the other one, okay? Because the lower limit and the upper limit is like repetition. That's why we've compressed the formula like this. So we can decide to write it this way also. But don't forget, plus or minus. So let's substitute. So since x bar is 7.1, then we replace x bar with 7.1. And then our t-score was 2.262. So we replace the t here with 2.262 times. The sample standard deviation was 0.78. So we substitute it there. And then divided by root n. So our sample size was 10. So that will be root 10. So when you check 2.262 times 0.78 divided by root 10, you get 0.5579. So you are going to have 7.1 plus or minus 0.5579. So when you get to this stage, you first take 7.1 minus 0.5579, and that will give you 6.5421. In 2 decimal places, that will be 6.54. And then you also take separately 7.1 plus 0.5579, and that will give you 7.6579. And it will be 7.68 in 2 decimal places. So the final answer is 6.54, 7.68. You can also write your answer as 6.54 less than mu less than 7.66. Remember, if you leave your answer in 2 decimal places for the lower limit, then the upper limit should also be in 2 decimal places. If the lower limit is in 1 decimal place, the upper limit should also be in 1 decimal place. If the lower limit is to the nearest whole number, then the upper limit should also be to the nearest whole number. So you conclude that one can be 95% confident that the mean time will be between 6.54 and 7.66 hours. So let's look at example 2. Example 2 says, the data represents a sample of the number of off-campus night attack cases reported for the past several years. Find the 99% confidence interval for the mean number of off-campus night attacks that occur each year. So we have 12, 15, 8, 20, 10, 17, and 10. When you look at this question, you realize that you have to find everything yourself. You have to find a sample size yourself. You have to find a sample mean yourself. And you have to find a sample standard deviation yourself. So to solve that, you get a sample size by counting the number of data values. So we count 1, 2, 3, 4, 5, 6, 7. So the sample size is 7. Then we find a sample mean. The sample mean is summation x divided by n. Summation of each value divided by n. So when we add each of the values together, so when we take 12 plus 15 plus 8 plus 20 plus 10 plus 17 plus 10, we'll get 92. So the sample size is 7, so we have 92 divided by 7. 92 divided by 7 will give us 13.14. So 13.14 is the sample mean. So let's find a sample standard deviation also. To get a sample standard deviation, the formula is square root of summation x minus x bar squared divided by n minus 1. Now to compute the standard deviation easily, let's draw a table and then we fix all the x values under the x. So we have 12, 15, 8, 20, 10, 17 and 10. Then after writing all the x value, then we draw another column for x minus x bar. So x minus x bar is known as deviation, okay, deviation, x minus x bar. So to get x minus x bar, we know our x bar to be 13.14, isn't it? So to get x minus x bar, you take the first x value that is 12. So we say 12 minus 13.14, and that will give us negative 1.14. Then you go to the next one, 15 minus 13.14, you get 1.86. Then 8 minus 13.14, you get negative 5.14. Then 20 minus 13.14, you get positive 6.86. Then 10 minus 13.14, you get negative 3.14. Then 17 minus 13.14, you get 3.86. Then 10 minus 13.14, you get negative 3.14. And after getting each of these values, then you also create another column for deviation square, that is x minus x bar square. But I just write it in short, d square. Since x minus x bar means d, then d square, okay. So d square is the same as x minus x bar square, okay. It means that we should square each deviation. So let's square each deviation. So negative 1.14 square will give you positive 1.2996. Please bracket the negative 1.14 before you square it, so that I can get a correct answer. Then 1.86 square will give you positive 3.4596. Negative 5.14 square will give you 26.4196. 6.86 square will give you 47.0596. Negative 3.14 square will give you 9.8596. And then 3.86 square will give you 14.8996. Negative 3.14 square will give you positive 9.8596. Please check that with your calculator also. If I've made a mistake, you can let me know. So after getting all the d squares, then you add them together to get a numerator in this formula. That is summation x minus x bar square. So when you sum all the d squares together, you get 112.8572. So that is what you substitute for this place, the numerator here. That is summation x minus x bar square. The 112.8572 you've gotten means summation x minus x bar square, okay. So let's substitute it in the formula. So we have square root of 112.8572 divided by, our sample size was 7, isn't it? So we have 7 minus 1. So when you check 112.8572 divided by 7 minus 1, you get 18.8095. So you have square root of 18.8095. And then when you check square root of 18.8095, you get 4.33699. And then you can leave your answer in 2 decimal places, and that will be 4.34. So this is the sample standard deviation, and this is the sample mean. So after getting the sample mean and the sample standard deviation, you can now go ahead to find the confidence interval. Our sample size is 7, our sample mean is 13.14, and then our sample standard deviation is 4.34. So let's find a t-score. To get a t-score, we need alpha over 2, isn't it? So our alpha over 2 will be 1 minus c divided by 2, and that will be 1 minus 0.99. Remember, we convert the 99% to decimals. So 1 minus 0.99 divided by 2 will give us 0.01 divided by 2, and that will be 0.005. And then we find degree of freedom. Degree of freedom will be equal to sample size minus 1, and that will be 7 minus 1, and we get 6. So let's go to the t-table for the t-score. So you go to where they've written 1 table and check 0.005. So this is it. Against the degree of freedom of 6, so we get 3.707. So our t-score is 3.707. So let's record the formula for the confidence interval, and that is x bar plus or minus t multiplying standard deviation over root n. Remember, the reason we are using t in this topic is that the sample size is less than 30, and simultaneously the standard deviation is not a population standard deviation, it is a sample standard deviation. That is the reason we are using t, not z. So let's substitute in the formula. So since our sample mean is 13.14, we substituted there. So 13.14 plus or minus, we got a t-score to be 3.707. So we substituted there times. Our sample standard deviation is 4.34. And then the sample size is 7. So we have root 7. So 3.707 times 4.34 over root 7 will give you 6.08. So you are going to have 13.14 plus or minus 6.08. So you take separately 13.14 minus 6.08, and that will give you 7.06. You also take 13.14 plus 6.08, and that will give you 19.22. So your answer will be 7.06, 19.22. You can also leave your answer in the form 7.06 less than mu less than 19.22. So you can conclude that one can be 99% confident that the population mean is between 7.06 and 19.22. So that is the answer to this. So let's look at another example. Example 3 says, the US dairy industry wants to estimate the mean yearly milk consumption. A sample of 16 reveals the mean yearly consumption to be 45 gallons with a standard deviation of 20 gallons. Assume that the population distribution is normal. Develop the 90% confidence interval for the population mean. So to solve this, when you look at the question, the sample size is 16, so it means that our n is equal to 16. And the sample mean is 45 gallons, so meaning our x bar is 45. And also, the standard deviation is 20 gallons, so small s is 20. How do I know this 20 is a sample standard deviation? Now, look at this. A sample of 16, that is the subject, reveals, this is the verb, the mean yearly consumption to be 45 gallons with a standard deviation of 20 gallons. Meaning that this sample is what is revealing this mean and this standard deviation. This mean is for the 16, which is a sample. And the standard deviation also is referring to this 16, which is also a sample. So that makes it a sample standard deviation. So the standard deviation here is a sample standard deviation. Also, we need our t-score. And to find a t-score, we need alpha over 2, isn't it? And that will give us 1 minus c divided by 2. And that will be 1 minus 0.90. Since the confidence level is 90%, that's 0.9 or 0.90. So 1 minus 0.90 divided by 2. And that will give us 0.05. And also we need a degree of freedom. To get a degree of freedom, it is n minus 1. And that will be 16 minus 1. And it will give us 15. So we go to the t table. We check 0.05 at where one tail is. Okay, 0.05 against the degree of freedom of 15. So this is degree of freedom of 15. This is 15. So our t-score is 1.753. So we've gotten t to be 1.753. So we recall the formula for the confidence interval, and that is x bar plus or minus t multiplying standard deviation over root n. So let's substitute into the formula. So our x bar is 45 plus or minus the t is 1.753. And then the sample standard deviation is 20 divided by square root of 16. So square root of 16 is 4. And 20 divided by 4 will give you 5. So 1.753 times 5 will give you 8.765. So you are going to have 45 plus or minus 8.765. First, we take 45 minus 8.765, and that will give us 36.235. So to the nearest whole number will be 36. And then we also take 45 plus 8.765, and that will give us 53.765. And to the nearest whole number will be 54. I decided to convert this to the nearest whole number because the sample mean is also a whole number. Okay, so the answer is 36.54. You can also leave it 36 less than mu less than 54. So you conclude that one can be 90% confident that the population mean will be between 36 and 54 gallons. So our next topic is confidence interval for population proportion. You can check the link for it in the description area below. If you have not subscribed to the channel yet, do that now so that you can easily see the other videos. Thank you.